All right. Well, we'll get started, everyone. Thank you all for joining us for this webinar. We're very pleased to work together with Mark Roberti and the other presenters to put together this webinar for you. Today, I'll play a role in talking about some best practices for deploying RFID in harsh environments, and we'll talk through some of those things. First off, a little bit about us as Omni-ID. We are the #1 supplier and manufacturer of UHF RFID tags for industrial applications, harsh environments where we live. We started out doing on-metal passive RFID and continue to be the leader in that market, doing a lot of applications in some of the very most rugged environments on Earth. A lot of first-to-markets in our portfolio, lots of different awards, and a significant patent position for us. So if you don't know about us, you should. And if you're considering a harsh environment project, in addition to the many other great presenters that are on this call and others that you'll meet, you really should check out some of the capabilities that we have, and hopefully we can help you, as we do many folks. Our agenda today is to talk about best practices in RFID, and specifically talk about kind of a top 10 harsh applications list. I'll try and share some examples and to go through some of the learnings that we've had in this list, and perhaps it'll stimulate some ideas for you on how you might want to approach your harsh environment auto ID RFID project. So first off, identifying requirements is the key. Many companies come to us with an idea that they want to get control of their assets, they want to get control of their vendors, maybe even control of their people. They see a tagging project or an RFID project as a way to do that, but they have a very rudimentary concept on what they're trying to really get done and what the benefits they're trying to achieve. A lot of our work starts right here, identifying the business and the use cases, what kind of costs, what brings ROI, what kind of benefit can be achieved by a more specific tracking program, and being able to identify those things moving through the enterprise. So your first checkbox should be focus on your business and use case. Assume that the technology can identify the asset. Assume that it can do it in real time and in multiple reads at the same time. And if that assumption is in place, what will that do for your business? What kinds of changes would you do to your workflow? What kind of use cases would you bring to the table? Try and get those together on your own, and then of course once you meet first with your knowledgeable partner, they can flesh it out a little bit more with you. But that's got to be the focus of every project. Unfortunately, we find too often people are wooed by the technology and they get to the business case a little bit late in the process and find out it really isn't going to achieve what they're trying to get to. Once you're there, because we're speaking specifically about harsh environments, there's a few things that you need to think about. Very top of that list is durability and attachment method. There's a lot of really difficult durability environments that we deal with: chemical exposure, sandblasting, impact of heavy equipment, in some cases tamper-proof requirements. So think about what you need for your application in terms of true durability and how you'd have to attach a tag. It's not magic. Something has to be there to put it together, and that's got to be a key part of your project. Then you've got to think about environmentals, your temperature, your UV exposure, humidity or moisture. Is it indoor, outdoor? You know, there's a lot of things to think about in the environment, and sometimes that will dramatically change the choice of technology and certainly the packaging and the way it's going to be attached. So get your environmentals clear in the way that you're going to use it. For all RFID projects, whether they are harsh environment or not, read range is a key thing to assess. Do you need portals? Are you going to be using handhelds? Are you going to do multiple reads on the back of a flatbed truck? And you want to have a distance that you can see everything that's on that truck. Think a little bit about that read range. I mentioned in this list angular requirements. It really does matter a lot at what angle you're going to try and read those assets at the point you're reading them. Is a man on the ground, and is he pointing up at a stack of goods that are maybe 20, 30 feet high? That angle, that read angle, will make a difference in the type of technology deployed, the type of tag deployed. So think through all of your use cases and think about both the range and the angle and the type of reader you'd want to use in your business case. The good news for you is that the technology's improved so much that there's great options for all those things. Almost every problem can be solved with either a special tag, a tag variation, a reader, a different kind of antenna configuration. But having those requirements on the table will avoid surprises later where you've invested in things that won't work once you get to the real application, now that you've thought about it. And lastly, the IT and the infrastructure. All of these things are hooked up to back-end infrastructure, and you have to understand, what is your IT strategy? Are you cloud-based? Have you got a premise-based server? Are you deploying mobility devices? Do you have to have people on forklifts or on high-lows that are able to get these reads? And what's your IT strategy for those? What's your authorization levels in terms of sign-ins and enrolling people and enrolling new assets? All those things will be impacted by the IT and infrastructure plan that you have for the project. So that's your key checklist. Make sure you've gone through that. The icons on the right really talk about the parties involved here. It really works well if you can form a project team early in the project. Get your business owner who understands the business and use cases that the enterprise is trying to achieve. Make sure they're crystal clear on how they want their people to be operating in the yard or on the floor. Pardon me. Or on the floor. But then bring in an experienced integrator, an experienced RFID vendor who can actually counsel and work with that business owner to say, here's what the limits of technology are, here's what we can do, and to work out those problems. It's very rare for us to find a project, especially in a harsh environment, where everything just works out of the box. In almost every case, there has to be a little bit of give and take on the physics or on the material science or on the adhesives to make sure that everything works. And so that party of three that you see on the right is crucial. There should be early meetings and then often meetings through the project to make sure everybody stays synced up and on the same page. All right, let's talk about some typical applications just to kind of stimulate that thought, but keeping in mind those 5 key bullets that we just talked about. So one of the classic parts of harsh environment is yard management. Yard management is difficult because it's outdoors. Depending on the climate, you can either be baking in a hot, soddy desert, or you can be up in the northern part of Canada with your assets laying out in the middle of the wilderness covered in snow and ice. Yard management has all the elements of harsh environment that make it tough. So you have to think about how big is your yard? Are there choked off access points? Are there places that we enter and exit, to bring these assets back and forth? How long will they lay there? What kind of durability does the tag have to have for sunshine, for heat, for cold, for ice, for water, and go through all of those different questions. A lot of great technologies to solve each one, but it's really important to think through that. One of the things to stimulate thought, you see one of our products on the right-hand side, a power tag. It's a tag that we have installed both in soddy deserts and up in northern Canada, and we get tremendous read ranges, in some cases up to 1 kilometer in the right situations, and it can project right underneath. We've had it projecting from under 6 feet of water or 4 feet of ice and still being able to be read at great distances. So if you thought before you were managing a yard, maybe 10 years ago somebody tried to do RFID in the yard and it failed, one of the messages I'd like you to take from this webinar is that technology has improved tremendously. We can do things that weren't possible 10 years ago, both in terms of surviving the environment and also having RF performance that will probably surprise you in terms of the distances and the reliability that you can get. So think about that when you think about your yard. The other thing, as I mentioned on the slide about ATEX certification, we're also able to deploy RFID in explosion-proof environments, harsh environments where you've got oil and gas operating and you have to worry about exploding. So think about that. Costs have also come down tremendously from where we were before, and especially on infrastructure, there's a lot of options there too, but I'll talk about that a little bit at the end. High impact's another application. We have lots of applications where there's a lot of clashing together of assets, whether these are pipes that are coming together or different skids and lids that get thrown around a little bit. A lot of tags are designed now for that kind of impact. You see an example on the bottom right here of an all-metal tag. This has got a stainless steel protective cover around it where you can literally pound on it with a sledgehammer and the tag will still survive. I think tags weren't like that years ago, and you now have that opportunity to do that and still get tremendous read range, where you can read it while it's in a trench, read it when it's up on a scaffold, and still be able to see it. So I think that those are new things that maybe you didn't think of before. Chemical resistance, of course, can also be built into these exact same tags, but the real thing about the high impact is important, that even the RFID chips can survive in these really difficult high impact environments. Some of the stats you see on the side, 2,000 kilograms of compression on some of the tags that we make certainly will survive significant environments like this. Okay, next environment we want to talk about is explosive environments. We're increasingly doing more and more of this as the oil and gas market picks up again, and we're seeing a retrenching here and an expansion in that marketplace, which is great to see. But explosive environments are quite common around whether it's oil and gas and energy projects or munitions with our military, places where we're doing exploration and dynamite. So explosive certifications are not to be messed with. You need to make sure that you have the right certification on your equipment, whether it's an ATEX or a Class 1 Div 1, Class 1 Div 2 certification. You can look for vendors that have those. There's plenty of suppliers now that can certify their equipment and their tags for that application. So if you thought that that wasn't possible, make sure that you know now it is. There's lots of elements to this that are key. In some cases, there's a requirement to overmold or to cover the tag with special static discharge coatings that dissipate the electricity buildup on the surface of the tag. So think about that that's possible and certainly is supplied by us as well as a number of others, I'm sure, in the marketplace. High temperature comes up quite a lot, and I'll mention a few different use cases here. High temperature can be the result of a natural environment, as we talked about. We have many deployments that go into Middle Eastern deserts where that direct sunlight on the tag can really heat it up to tremendous temperatures. But in a more controlled environment, we talk about things like autoclaves in healthcare or paint booths in automotive as classic high temperature applications. You see on the right some of those highlighted. The top right is a tag that's made specifically for paint booths and is excellent even when it's coated with multiple layers of paint and going through multiple times a very high heat enameling process. It can survive that very, very well in a repetitive nature. Medical instruments have been talked about a lot. Putting medical instruments into sterilization chambers through autoclave is a very common desire. While that market has had a lot of activity, I'm not sure there's been a lot of really large deployments or broad acceptance yet, but it's certainly bubbling along. And the solutions are there now to be able to tag them. It's really some other pieces that have to be put together commercially to make it go, I think. But if you're involved in any of those kinds of projects, you should know that the technology is there and able to be delivered now to satisfy those kinds of environments. Up to 225, 250C is very common. Moving to the next. High memory. While we don't always think about that as a harsh environment application, it usually is. Almost all of the high memory projects that we've done have involved manufacturing or processes where there's a lot of work being done in an isolated area, which is typically harsh, where you want the information to flow along with the tag. Just to put that in setting, many folks have the philosophy that the tag should just be a license plate, an ID number, and all the data associated with that ID number, the asset type, the attributes of the asset, the vendor who made it, would all be up in some software in the cloud, and you read the license plate and you can pull down the data. That's generally the right strategy. Keep the tag simple and have the data in the software. But there are applications where that's not as possible. Those applications can involve automation like PLCs, where you want to be able to pull the information directly from the asset. And it also can involve applications where you're in a remote area and you want the information with the asset because you may not get connectivity to either your software or to the cloud. So high memory can be required, and usually that's in a harsh environment. Traditionally, HF tags have really played a good role here. I show one there in the top right-hand corner. You can get tremendous memory sizes in HF at reasonable prices, and I think that's a really good choice for high memory. The challenge is when you need high memory and long read distance. And in some of these applications, especially in manufacturing, that's the requirement. You need to have the readers be set far enough back that humans and machines can step in between them and the asset, and so you need read distances of a few meters, maybe up to 4, 5, 6 meters to be able to work effectively with the asset. So we have a product down the right-hand side that shows that in UHF format, but the reality is either HF or UHF are great options now for doing high memory in a harsh environment, and these tags can survive tremendous impacts as well as environmental conditions in those environments. Something you don't often think about in harsh environment is the effect of a noisy environment or RF interference. There can be some really difficult situations where there's a lot of radios involved, a lot of automated equipment like AGVs that you see in the top right. They're all run off of radio networks on different frequencies. And it has not been uncommon for us to run into a project where there's been a degradation of performance, and when we arrive with our spectrum analyzer and we try and take apart what's happening, we understand that there's been some interference from different equipment that's on site, especially in these harsh environments. A great example that you see down on the right, that was one of my favorite stories. We had a set of Wi-Fi tags that were being used, and we had real difficulties at different points of the day where the system would have constant increases in failure rates. And when we went to troubleshoot on site, we realized that there was a big lunchroom. They actually had over 30 microwaves in the lunchroom, and when the employees went for break and they fired up all those microwaves, that interference knocked out the system, or a good portion of the system, and caused an increase in the failure rate. So you find it in the weirdest places that that interference comes from, but the key is to realize that your site could be noisy, and you need an RF expert to understand that and assess that and figure out ways to isolate it. Once you know that there's a source of noise, you can deal with it with high and low pass filters and different ways of getting around it, but it's about diagnosing it and finding it. Far too many projects have inconsistent read rates, and they blame all sorts of things. They'll blame the tag, they'll blame the reader. Quite often it's really just about the noise that's being generated, and you need an RF expert to figure out what that is and then mitigate it. So that's a key one. Chemicals are really important. Increasingly in our world, we're using more and more derived solvents, derived cleaning fluids, different things that are not part of our natural world, and the interplay between them takes real material science to figure out. We employ for that reason some material scientists that all they do is work on glues and overmolds for the many, many different operations that we have. It's not something you should really guess at, and even comparing some of the spec sheets doesn't always do what you need in terms of looking at chemical resistance for different materials. So take this one seriously. If you have either lubricants or cleaning fluids that you're using habitually on your site, in your environment, expose them to your integrator and vendor team. Make sure they understand those clearly, and hopefully they'll have the right material science folks in place that can analyze that and make sure that you won't have a problem later on. But again, there's been great advances in this, and there's a lot of different ways to mitigate this once you know that that's the problem and understand how to mitigate it. A real fun area here that we've been dealing a lot with, and I know some of the other folks on the call here as well may speak a little bit about it, is anti-tamper or counterfeit environments. And it may be a little bit odd to put that into a harsh environment webinar, but again, we find that a lot of these are in harsh environments that we're dealing with this. There is certainly another branch of this with NSC where you're worrying about financial transactions. That's really kind of outside the scope of this day's topic. But for today, we talk about large capital assets that are being shipped to sites into major infrastructure projects. There's increasing requirements now to validate the origins of those pieces of capital equipment. Even some of the Homeland Security requirements are now coming up where they're trying to verify that they haven't been tampered with, or that doing some anti-terrorist work on key things like dams and bridges to make sure that there's no counterfeit materials or that there hasn't been tampered materials going into a project. That stimulated for us a tremendous uptick in anti-tamper and anti-counterfeit work. Tags inherently are better than things like labels because you don't see what's in them just by looking at them. But that's really not sufficient. You want it to be that when you interrogate a tag, that you can't easily clone the tag, that you can't have a set response, because an RFID tag can be cloned, and you can copy it just like you copy the big piece of equipment if you're intent on doing so. The way to counter that is to have it have a private key encrypted directly into the tag response, and that makes it impervious to that cloning exercise. If you didn't know that that technology is available, you should know it is. The technology is advanced to the point where you can make it completely secure. Combined with the fact that you can now physically mold these tags directly into metal, and you see pictures of that on the side, whether it's a bolt or a pipe or some large valve, we're able to put these in with a metal-bound epoxy that's almost impossible to remove without physically drilling and changing and altering the product. You can get a very, very secure anti-tamper or anti-counterfeit tag. If you're not into the very rigid, mold it in and embed it directly, there are other ways that you can have sensors involved where if it is detached, you can flag that detachment. And sometimes that's all that's required, whether it's magnetic latches or whether it's just a sensing of the characteristic impedance of the host substance that you're mounted on. Those things are possible as well. So if your harsh environment requires some kind of anti-tamper or anti-counterfeit application, realized in the last decade we've come a long way here, and there's a lot of great solutions for protecting your equipment and making sure it's authentic and hasn't been tampered with. This wouldn't be complete without talking about infrastructure, and so I'd like to dwell on that a little bit as we wind down to this particular segment of the webinar. When we pull this all together, think a lot about your infrastructure. A lot of folks have been around RFID for a long time, and they have a very classic view of portals and antennas fixed mounted. Even in doing a harsh environment yard, the first request usually comes to us about creating a big gate and having those antennas there fixed mounted. And that may be great. That might be the right thing for your application, but more and more our programs are becoming more portable. They're becoming lighter touch. The infrastructure costs are coming down dramatically, much, much cheaper than it used to be, again, 10 years ago. One example you can see here, this picture of our Marine Corps friends, a major customer of ours, as they read assets coming on and off of some of the boats as they deploy in different theaters. They use a solar-powered reader that they stick on a pole. And we've been with them as they've jabbed it into the beach and watched tanks and Humvees coming off of a boat and scanning them as they come up the beach. Very, very simple to deploy, very, very cheap. It goes with the forward unit, and you have an ability to go ahead and read things immediately without any kind of permanent installation and at a very reasonable cost. So that can apply for some of our other projects that we have. It doesn't have to be military, where you can use something like that as a mobile solar-powered fixed reader. Probably the hottest topic we have when we're talking about harsh environments, because many of them are outdoors with big areas, are drones. Drones have taken off all over the world, no pun intended, as a great inexpensive means to deliver goods, to survey places, to take pictures, and to generally keep track of different things. RFID is another great application for drones. We work with at least 4 different companies now that will mount a small reader with us. We'll be able to read their active or our passive tags and have that drone fly a circuit. We've done some white papers that are published to talk about that, but it's a really effective way. When you think about what it used to be, if you had a 5 square mile yard with a bunch of pipe spools laid down, and you'd have to put down fixed infrastructure, run cable, run poles, put up antennas, the cost is just tremendous for that kind of infrastructure. Today, we can take a drone with a little docking station, and every day at 4 o'clock, the drone can come out of its docking station. It can fly a predetermined route based on GPS coordinates, fly its grid, and do a full sweep of the yard, come back in and dock in its cradle, and upload all of its information to tell you exactly every asset and where it is in the yard. We correlate the reads to the GPS off of the drone, so we can locate where the asset is from its signal strength versus the GPS. We can multilaterate, so that when we take multiple readings of the same tag, we can position it in a real-time fashion to know exactly where the asset is. So for a few $1,000s, you can have a drone do your grid, eliminate a person doing inventory, and eliminate all that fixed infrastructure that used to be traditional. So probably the biggest growth in this area has been for drones for us, and we're seeing many, many more projects going that way. Mobility devices, of course, are also popular, smartphones, tablets. We have a lot of portable Bluetooth readers that can be coupled up with those smart devices. And those are really handy if you already have people going through the yard who already have a mobility device. It's a very inexpensive thing to make that as an add-on, add a reader to it and be able to read some of these tags and do sweeps. It goes back to the IT structure we talked about before. If that's your IT policy and the way you're going to run some of your other apps, because RFID, of course, is really just giving information into somebody else's application. If you've got an application already running on a mobility device, it's a great solution to add that extra reader. And I wouldn't, of course, discount the gates and portals, which still make up a large part of our installations. Once you've gone through the hardware and you think about the tagging and the infrastructure, and maybe long before that, you think about your software. RFID can either be put into an asset management application. We have many partners in our ecosystem that we work together with to do turnkey programs where they'll supply their great asset management software, bundle it together with tags and readers, and produce a full turnkey application for you. We also do a number of projects where you already have your software in place to run your enterprise, whether it's an MES or a WMS system, and you just need to get more real-time feedback into that. For that, a simple piece of middleware can be put in place that acts as a RESTful service. It can pick up some of the data from the various readers or drones or or devices that are deployed to scan the tags and tell you where your assets are, and then give that information back up to the higher level system as reads. Completely headless and very inexpensive. So if you don't want to change your environment, but you just want more real-time information, you might want to opt for a middleware device management strategy and keep your existing software, just integrate the RFID reads into it. All right. With that, I think I've come to the end of my time at the bottom of the hour here. I hope that it's been informative for you to look at these different top 10 applications and the constraints on them. I'm ready to take some questions if anyone has questions on any of those or the best practices we discussed.
Okay, Ed, thanks very much. Terrific presentation. Folks, if you have a question, please enter it into the question and answer tool. Just click on Q&A or the question mark up in the upper right-hand corner of your screen. Type in your question, and I will present that to Ed. Ed, you mentioned early on in the presentation, think about attachment methods. What options do folks have for different attachment methods?
A whole lot, probably more than we had before. So there's traditional mechanical attachment. We do a lot of bolting and riveting of tags. We also do some pretty interesting barb and high-speed nail. So mechanical attachment is a very popular one in a harsh environment. But the other one that's really popular are adhesives. And there's a lot of really excellent both wet and dry epoxies and adhesives that can be used for different environments. On the adhesive side, that's where that material scientist comes in that we talked about before. You really want to make sure you've validated your adhesive with the temperature, the environment, the chemicals that are going to be used on the site. But there's lots of great options to make that work. We also sometimes make special clips, to hold these tags in, and that's also obviously an option too. But for harsh environments, I really recommend that the audience here think not about your typical Walmart slap and ship cardboard label. Because it's a harsh environment, whether it's mechanical or chemical attachment, you really have to make sure that you've got that right. One option I neglected to mention as well is magnetic. A lot of our harsh environments have metal assets, and so that's another option too. We do a lot of magnet tags just to temporarily stick it on.
Oh, that's interesting. What about embedding tags? Are more folks looking to embed tags directly into the assets?
Yeah, absolutely. It depends a little bit by industry. Some of the big metal movers want to put it directly in. There's also some great things we've done with shelving and hollow assets where we can work directly in embedding. So embedding is a growing area. It's a different kind of project. We're usually working directly with manufacturers and doing what we call source tagging, putting the tag directly into the asset. But it's certainly also possible to do embedded tagging in the field as a retrofit. And a good example that might be some of the medical instruments you're seeing done. We're retrofitting tags onto medical instruments as a project as well.
Right. Where are the private keys located or stored? Do I see the EFID or do I need to broadcast the key to the tag to receive the information?
Great question. Yeah, for security protocol, you have an embedded area in the tag. As you may know, that in our RFID tag, there are some areas of the tag that are very public, the EPC field being one of those. But in many tags, you have user memory that can be locked and encoded directly at manufacturing site. So for some of these tags that are made specifically for security, the private key is embedded directly in some of that memory. It's locked and it's made non-readable so that the private key is held there in non-volatile memory. Then the protocol allows you to pull from that and respond to a challenge from a public key holder who challenges the tag and gets the response from the private key that's stored in non-volatile memory.
Right. Okay. Thank you. For the drone use case, how fast does the drone fly? What is the read range from the drone, assuming that the antenna is smaller than, say, with a portal reader?
Yeah, great question again. Whenever you talk about read ranges, so first of all, how fast does the drone fly? We've had some military-based drones actually out of Israel that we've worked with that are really, really fast. They're made to go into theater and do forward deployment to protect soldiers, flying ahead and seeing what's going forward. But even with that, you're talking about speeds of 60, 70 miles an hour. An average drone doesn't fly that fast. You're more into tens, low tens of miles per hour in terms of speed, at least in a stable environment. But the read range, whenever you talk about read range with RFID, there's two sides to it. There's the reader and the tag. And depending on which tags you use and which reader you use, you get different read ranges. From a passive perspective, the passive reads that we've done for passive UHF RFID, we're usually dealing with something 35 to 50 feet of read range on our tags that we would use for a yard. Some can be less than that, and some can be even more. But say 35 to 50 feet is something that you could make a working assumption on and fly your drone over top of your assets for passive. A lot of our jobs will be active. For active RFID for outdoors, we recommend the 433 megahertz tags. They're really good and robust in wet conditions, snow, ice, as I mentioned earlier. For those, with a drone and a small reader, we're able to get 400 or 500 meters of read range in those kinds of conditions. The antenna, the advantage of having the drone is your antenna is very high off the ground, and that helps mitigate the ground reflections you typically get in an active RFID project. So you actually get superior read range from a drone in active RFID than you do from fixed infrastructure on the ground. In some cases, double the read range that you would have on the ground.
Right. Okay. Under software, you mentioned middleware. Is there a middleware that Omni-ID recommends?
Yes. We have our own middleware that we recommend. We often will do that, but we also have a constellation of partners, depending on the exact need. And everyone has slightly different needs. Some projects have a lot of different devices integrated. We have some partners that have middleware that can handle hundreds of different device classes. For more of a simple device management, we might use our own or use a different partner that might be more configured for that. So there's probably 5 or 6 packages, Mark, we would recommend depending on who's calling us and what they need to do. So our process is our inside sales desk typically goes through a number of questions. If the project warrants it, it goes to one of our field application engineers or to one of our key account managers. And once they've assessed what the customer really needs, we either recommend one of our own products or one from a partner company.
Right. Okay. Which tag would you recommend for tagging engine filters that go inside cars?
And that I have to give a question back. So an engine filter going inside of a car, do we need to read it once it's actually in the car and installed, or are we reading it just as it's going in or coming out of the car? Because that would make the big difference. And I know you can't answer that, Mark, because you're not the person asking.
Right.
Typically, an engine filter is going into a shroud. It can be a metal shroud, so you're in fact putting it inside a metal can. And it might be there isn't a good option to be able to read that through that can from outside the car's exterior. In that case, you might be using a very simple paper-based tag to match the filter itself and reading it as it's being put in and taken out. If you really need to read it through that shroud, there's very few options for you. You have to go to a very low-frequency tag that will actually be able to be read through that metal, something in the LF range, and that would be your only choice.
Okay. You mentioned early on read requirements. Do you have a list, or is there a list available of different read requirements that folks should think about as they're planning their deployment?
Mm-hmm. Yeah, I'm sure a lot of companies do different things. I don't want to be just Omni-ID on it, but if you went to our website, we have a number of classes or families of tags, and with them we have a selection guide, a very handy kind of grid, where you go through and you look at which tag is appropriate for which environment. In each of those grids, there's a section on read range telling you this one will go about this far, and it reads good from this angle or from that angle, and you can understand kind of what's best for your environment. So those are the tools that are available for you to self-serve, but of course we're always open to a conversation for you to talk to one of our specialists, and if they talk with you for just a few minutes, they can probably recommend the right tag for your application as well.
Okay. Has Omni-ID done any installations in the uniform rental sector?
Well, that's a great question. We haven't actually. One of the places we haven't gone yet with our product line is linens or clothing tags. And so uniform rental and wash cycles is not something that we're specialists in. We do have some partners we've recommended into this before, so if whoever asked that question wants to send that up to me by email, I can certainly point you to some partners we've used on projects when we've been involved in them.
Okay. Last question, Ed. What was the solution to the microwave ovens being used in the cafeteria?
Well, we actually found, I mentioned before a tool called a spectrum analyzer. when you can isolate at what frequency those microwave ovens exactly are emitting at, and again, 2.45 gigahertz is got some breadth to it, we were able actually to shift the tags up to a different channel where they can be mitigated from that key interference point. So we actually took them high. We went up above the 2.45, not up above the specific frequency band that we were seeing the emissions from the microwave.
Okay. Ed, thanks very much. We appreciate your taking the time to present today and for supporting this event as a sponsor.
You're welcome. Thank you for letting me be with you.
Okay.